Hello and welcome to our new lesson, Data Collection and Event Processing, which is Chapter 4 of the ESM 101 document. It has several sections and new concepts that we will learn together. The first section, or two sections that we will cover in this video lesson, is the Collect and Normalize Event Data. Next, we will study the Apply Event Categories, how we can change or override the event categorization of the events received in the ESM. Then we'll learn how the smart connectors is doing the customer and zone lookup in the network model. Why the smart connectors? Because we are in the collection phase, which is the first phase of the event lifecycle. So the first component that the event will hit is the smart connectors. So we'll learn how the lookup is done, and the lesson filter and aggregate events, we will learn together how to make a first level filtration and aggregation on the smart connector level. Finally, we will study the managing smart connector configurations section. So let's jump in and switch to the 101 document. This is the first phase, data collection and event processing of the event lifecycle. I'll just refresh your minds by this diagram. We already studied in the previous lessons. So we have 7 phases for the events coming from the log sources. So event data passed through this first phase, and the component in the ArcSight ecosystem responsible for that phase is the smart connectors. So we are in this phase now, and we will try to pass through the different phases. So coming back to our new lesson, data collection and event processing. Here is the first phase. The smart connector is the channel through which the events arrive in the ESM from the data sources. So you have the data source here, send some logs to the smart connector. The smart connector will start to do a lot of functions before it delivers the events to the manager, the ArcSight manager, or the ArcSight ESM, or the ArcSight logger, or any other ArcSight component that will process this normalized events. It's called normalized, the event after it passes through these different functions. It becomes a normalized event, or sometimes we call it a base event. So the first thing the smart connector is doing is to apply some normalization to put the logs into a common event format, common schema. We called it ESM schema. So the normalization is all about putting the logs which is coming from different sources and so in different formats into a common ESM schema, and it tags these events with categories. And as we see here in the diagram, categories is like tagging. You tag this log as an access log. You tag this log as authentication verification log. This is the tagging we mean by. And it also apply a first layer of filtration and aggregation, as we can see. Before that, we have the zone and customer lookup on manager. So the smart connectors download the network model from the ArcSight manager, and it looks up this network model to know the different endpoints represented in an event in the network model. So the smart connector can know that this event belongs to customer A. Imagine that you have a MSSP scenario. They are managed. They have a huge smart connectors distributed among many customers, and this send logs to ArcSight, big ArcSight deployment So it's multi-tenant, means that they are managing many customers, so they have many smart connectors distributed among these customers. So the smart connector must know which customer they are sending the logs or they are processing the logs for. So they get this uh, network model from the ArcSight manager and tag this log as customer A, this log as customer B, and so on. So this is the point of looking up the customer and zone in the manager. And then first layer of filtration and event aggregation to reduce the volume of the event stream. So first step is a normalization. Second, event categorization, zone and customer lookup. Then the filtration, aggregation, and finally you have events ready to be delivered to the ASM. This is called base events. Okay, so collecting event data. This we mean that the smart connector collect from different types of devices on the network like firewalls, IDS, and can connect from concentrator, which means centralized syslog server or any solution the customer have that aggregate or already the logs into one place. Still the smart connector can read from this concentrator. Then the data collected is actually log data generated by different types of sources. So we have different formats, and this is the point of normalizing event data. And here is a good example that you have log from a checkpoint from different devices, from checkpoint, from Cisco router, and from Snort. So you can see different formats. You need to be an expert in the three technologies to be able to read this. This is what the normalization means, or what the smart connectors are doing for you. So they are smart enough to recognize the different fields of these logs. So first, by the smart connector logic, it can know that this is checkpoint. How this is done, this is the patent behind the smart connector. This is, we don't know how the ArcSight engineers developed to recognize that this is checkpoint, this is Cisco router, this is Snort, but we can tell that this is content driven. They look for magic bytes inside every log. When they see these magic bytes, they know, or not bytes, magic characters, let's say, they know that this is a checkpoint, this is Cisco router, this is Snort. And after that, they can start to apply their parsers, it's called parsers, to which is content driven. So they know that this is a source IP, this is a destination IP. It's content driven and context based. So they know that this is a checkpoint, so they know that for checkpoint the source IP will be here, the destination IP will be here, and then it will be followed by the TCP. So they put the logic for or the context of how checkpoint writing their logs into their parsers, so they can recognize the logs and map them to the common event format or the ESM schema. And they have parsers for the checkpoint, for the Cisco router, for Snort, for around 400 plus vendors. So the first thing in the normalization, that it's content driven, it can recognize the locations of the fields and get to know that this is a source IP, destination IP, whatever, and put them in the ESM schema. Second thing, that it can recognize the different formats for the timestamp. So Cisco router is telling us the timestamp in this way, the Snort is saying the timestamp in a different way, maybe checkpoint is also different. So since the normalization started by recognizing the different types of the technologies that we have, it then knows how these vendors or these technologies are right there for right their timestamp. So the parsers again can convert this different formats to a common format for the ESM schema. So you can see here how the three logs are put in the ESM schema. So now the timestamps are the same. Okay, now the event names is extracted and put here the source IP. So this source IP is actually the same for the three log sources. We have a log on the firewall, we have a log on another firewall, the checkpoint, and it was what it was Cisco router. So access list, and we have log for, yes, here is the device type is written, Cisco router, checkpoint, and snort. So you have the logs now normalized for the analyst. The analyst can read this it's very simple and human readable for him. He doesn't need to be an expert in these technologies to read this. Okay, and the benefit behind the normalization also that the logs are in the chronological order of the logs are there, timestamps are normalized correctly, so you don't lose the sequence of the events. The attacker first, for example, first hit the checkpoint firewall and then hit the Cisco router and then the signature on the IDS getting fired, and so the sequence of events is there. So you can now start correlating these events together and select the related information, like source IP is the same. Find for me a signature triggered against my target server, and at the same time the firewall has accepted a connection. So you can relate this information together to get a correlation event out of all these base events. So these events, once normalized and categorized, filtered, aggregate, whatever the functions we spoke about in the smart connector, they are now become a base events qualified to be delivered to the ESM. Okay, so this is what is said here in the explanation. And important thing in the normalization is the event severity assigned to the logs. So the smart connector keep enriching the logs, keep normalizing the logs. So the event severity is actually derived from the device severity. So checkpoint put a severity for their logs. They say this is high or medium or low. Other technology like IDS will say this severity is 5, this 4, 3. So every technology or every vendor represent their severity in different way. So again, we need to normalize this, and here is a good example. If a network IDS detects a DHCP packet that does not contain enough data to conform to the DHCP format, the device flags this as a high priority exploit. Other IDS technology may say this is a severity 5. So again, we need to normalize this to a common format. This is the agent severity field come into action. This is a translation of the device severity into ESM normalized value. So for example, Snort uses a device severity scale of 1 to 10, while Checkpoint uses a scale of high, medium, and low. ESM normalizes these values into a single agent severity scale. The default ESM scale is low, medium, high, and very high. So the event can be classified as in our case, this example, the 1 to 10 for Snort, this 10 will be mapped to very high, for example, and this one will be mapped to low. For the checkpoint, you have a scale of high, medium, and low. So the high will be mapped to very high, the medium will be mapped to medium and maybe high, and the low will be mapped to low. So this is a normalization, how it happens. Okay. Another example, it said routine file access and successful authentications by authorized users would be translated into the ESM normalized value as low severity, while short DHCP packet would be translated as very high severity. It gives you another example of the event severity, how it's getting mapped from device severity to the agent severity. And actually, this agent severity and this device severity, agent severity are contributing in the calculation of the overall priority in the ESM. When we see I will switch to the ESM console. Remember, we already integrated some FortiGate logs in the hands-on exercises, lessons. So we can see here the overall priority. This is the agent severity levels derived from the device severity, as we just explained. So we have very high, high, medium, low, very low. So actually we have 1, 2, 3, 4, 5. They mention here only low. Where is the ESM? Normalized value. The scale is low, medium, high, and very high. I think this is not correctly updated. Needs the documentation for ArcSight, Microsoft Micro Focus ArcSight need to be updated to display. We have another level called very low. So very low, low, medium, high, and very high, according to the interface version 7 we have here. Okay, so you can see the FortiGate logs are now categorized or classified according to their priority. So we have like 1,200 medium, we have 5,000 low, and 0 very low. If we click like this medium on the fly channel, you see grid between parentheses. We have analyze in channel. So this medium logs are just displayed for us here, and they are getting updated. And the filter, you see the filter is updated from agent ID equals syslog connector 1 to just to be more restricted to the priority 5 or 6, and this are the medium scale for the event logs, the medium event logs. So if you click on one of this and you go down, here is the agent severity medium, and if you check the device severity, it's warning. So for this technology, for the FortiGate, the Fortinet FortiGate, they have different severity levels. One of these severity levels is called warning. This is a device severity. This is getting mapped by ESM, by the smart connectors to medium. Okay, if you go back here, I will go to this grid, the original grid with the only agent ID equals syslog connector 1. And if I click here again, low, so I will click choose the next or the lower priority logs, and keep an eye here, as this once I click, another grid will come here. So if I click the low, we have another grid, and now the filter, the original filter, the parent filter derived syslog connector 1, and priority is now 3 or 4. These are the logs. If you click here, you will see the agent severity is low, and if you scroll down, you will see the device severity is notice. So you can see how the device severities are being mapped to the agent severity, and this is one of the normalization that is being done by the smart connectors. Is actually doing a fantastic job for us to get the logs on our table in a common format. I don't need to think about how FortiGate classify the events, how what is the naming of the high important logs or the low important logs or the medium. I don't care about how FortiGate calls the severities or define the severities for those effects. I only need to know that there are 5 levels in ArcSight. And all these technologies are mapped to these 5 levels. And you see how the interface is easy to quickly pinpoint, and this is the triaging done by the SOC engineers to find the events of interest quickly from this nice UI. So that's it for this video, and thanks for watching, and see you in the next video.